All right, let's talk about the homework assignment first, or the report first, and then we'll write some code. I gotta wait for this the coffee. This is actually thick. It's like a syrup. Wait for the coffee tea mixture to start kicking in. So it's perfuming right now. All right, so write a 2 to 3 page paper discussing the concept of a MUD as it relates to multi-user dungeons. These were text-based dungeons with Dungeons and Dragons games similar to what you are writing in your homework assignment this week. What was the first MUD? What were the different types of MUDs? Do people still play MUDs today? What modern genre has completely replaced MUDs? Blah, blah, blah. So tell me what you found out. Anything interesting related to MUDs in your papers? Oh. That is just nasty. Oh. Don't all speak at once. We wrote the paper, right?
Yep.
Were we under the influence of some sort of tea and something? All right. So what was the first MUD? Do we see one of those?
Mud.
Okay, just called MUD.
Yeah.
All right. Tell me about it.
Was created in 1978.
Okay, 1978. Good year.
In UK.
All right.
Person's name was Roy something. His name
It's the same
was
something.
Roy. I don't know his last name.
Okay.
Whatever. And in 1980 changed to Mud 1.
Okay.
6 months.
Now, how were the original MUD set up? Was it so? How many users were in the original MUD? Anybody get that out of it? Go ahead. 2 users. Okay. So, and how was it implemented? Was this over like dial-up connections, or this was 2 people sitting connected to the same computer? Same. Okay. Same program, same computer. Just happened to be 2 people interfacing with one program, right? So kind of that, almost like using Microsoft Word and having 2 people working on the document at the same time, but sitting like right next to each other. Something like that. Okay, but kind of that initial concept of 2 people, 2 users we'll just call it a game at this point, experiencing the game world at the same time. Okay, let's see. What were the different types of MUDs as the technology evolved? What were the different types of MUDs?
7 types.
Okay.
Graphical, educational, social, hack and slash.
Okay, my favorite. So punchline being, they took this concept. So we have this tool. More than one person can be in this shared experience at the same time. It's a text-based shared experience because we had limited technology. But that was cool back then. Did anybody in doing this paper, did any of you actually go on to a MUD and see what they're like or anything like that? Like a video of somebody playing it? Okay. I mean, it's actually quite fascinating. And when you get into a MUD, when you actually play one often, I think it could become even more, I don't know if it's the right word, exhilarating. Whatever the word is in there, than some of our like modern games. Because so much is left to the imagination. Right? So when you're playing a video game today, all the graphics and stuff are on the screen. You see all the explosions and that kind of stuff. But if you're playing, like I joked when you said hack and slash. So I used to play these MUDs a lot when I was younger, and so I remember this one game I played was called FIDAR. It was a hack and slash type MUD, and during combat, you would, as your guy got stronger and stronger and stronger, and you started hitting the opponents harder, the words that showed up on the screen allowed you to kind of imagine what did you just do. Your swing just liquefies the opponent. Like, oh, how hard did I hit him? Right? Where if you're playing a video game today, and you're swinging an axe at somebody or something like that, the graphics tell the story, right? And usually it comes up south of liquefying, right? Or eviscerating. And eviscerating was always in big all caps and in red. I hit him hard, right? So I think there's a level of, since it left it to the imagination, very intriguing. And if somebody who didn't know what you were doing is standing there watching you, you're just sitting in front of a text-based screen of just text scrolling by. Basically, it looks like you're working on a term paper, right? It's kind of just an interesting thing, and how the power of imagination can go that far. And so, kind of coming off of that a little bit, do MUDs still exist today? Yeah, people still play them. Yeah. Huh? Well, they definitely exist in another way with more modern games, but do text-based MUDs still exist? They do. They're certainly not popular like they used to be. If you, there's the people who play the text-based MUDs today. Have you ever been to like the mall, one of the malls that has like a game store in it, but not like GameStop. I'm talking about like a card game store or that has a whole bunch of different board games and that kind of stuff. Yeah. So, and you know how they have the tables set up in the back where people go in there and play their games? And on one of the tables, you see like 4 or 5 like 50-year-old dudes like playing some, it's creepy, right? You know what I'm talking about. Yes. Okay? So those are probably the guys who are playing MUDs.
That's what I thought of when you first mentioned what they were.
Yep.
Because when I was working at Bayshore Security, oh my goodness, Board Game Barrister, they had the whole back hallway just full of stinky gamers. All of them came in capes and hats and everything else, and then they would sit there all day. They would stink so bad. It was horrible.
Did you ever get to shoot any of them?
No.
They didn't let you carry a weapon as a security guard there?
No.
Taser?
And a flashlight.
You couldn't have accidentally tased one of those dudes?
They didn't become rowdy, so we never had problems. Trust me, I wanted to just for the fun of it, but those weren't my even days.
Now I'm kind of like those guys.
Yeah, but you're not as weird, and you don't come in stinky. So
I draw lines, right? But in any case, it wouldn't surprise me if the older group of people who play those tabletop games, which are an older genre of game, but it still exists today. In fact, in a lot of cases, they're coming back. Some of these games are becoming popular again. And I think that the story you just mentioned, I think they just this last weekend had a tournament for some old board game that, has been out for 40 years, 50 years, something like that. And just more recently, it's just started picking up a little popularity. And so now people are coming back and playing this old board game instead of sitting in front of, instead of sitting in front of your computer and sitting in front of the Xbox, TV, whatever, people are starting to play these old board games, which have fallen out of favor. So kind of an interesting connection here. Let's see. So in any case, we have this tool, this multi-user dungeon, that's just a shared experience, shared text-based experience, and we decide, so when we talk about the evolution of this, how did we take this tool and apply it to different problems? So you mentioned education. So now all of a sudden kids found it cool to be able to go into, this is in the earlier days of having computers in the classroom, or at least computers at the school. If kids can go in and have the shared experience, in a virtual classroom, virtual text-based classroom, where they were interacting with, non-player characters or something like that in there that were there for education reasons. Or it was a chat room, the early chat rooms, when chat rooms were cool. Right? Nobody references chat rooms anymore, right? But, in the early days, they were cool. Then you had, the virtual chat rooms where you had an avatar and you went into a graphical world and, that was the person that represented you in that world. And so this was really kind of the evolution of some of these technologies. But MUD was even before that, where you didn't have a visual representation. You would just go in there and see, oh, these other 8 people are in the same room as I am. Hi, others. And you'd start texting and, typing stuff. So in any case, we saw the evolution of this tool get applied to a bunch of different things. And we see that with video game technology today. Maybe an interesting connection would be Oculus Rift. How many of you are familiar with Oculus Rift? It's a virtual reality headset that has been fairly popular over this last year. A company made it so they have a virtual reality headset thing that developers can write software for. And the idea is that, from a video game perspective, wouldn't it be cool? You put this helmet on and now you're in the game, right? You turn your head, boom, now boom. Anywhere you turn, that you're looking. But now they're starting to apply that to a bunch of different problems. They're applying it to education, social things. They're applying it to medicine. So imagine a surgeon controlling a robotic surgery table out in the battlefield somewhere. Surgeon's wearing the helmet and actually performing the surgery from across the world, all looking through this helmet as if he's there.
That's crazy.
But it's like, really interesting stuff.
Yes.
Applying those technologies.
I actually had one of those little helmets when I was a kid.
Okay.
And then my mother bought it for me from Walmart. I think it was Walmart.
So Walmart sold VR helmets when you were a kid?
It was some toy.
Okay, I got you.
And so me and my cousin both had one, and we went around the house playing with it. And then I had a little fighting game on there, and I accidentally kicked her in the chin. It was quite amazing.
I see.
Yeah.
Oh, well, I think, was it a Nintendo thing?
Yeah, I think so.
Nintendo VR, everything was red? Wasn't everything in like red color?
This one had other colors.
Okay.
But the little head thing I always
I see.
Yeah.
I don't know why this brought this memory up, but when, actually, do they even sell like at-home laser tag kits anymore? You have like professional places where you can go do laser tag, right?
Mm-hmm.
When I was a kid, laser tag kind of, became a big deal, and you could like buy. There was like 2 or 3 different competing companies where you could buy the laser tag gear. And I don't know why this memory came up, but like me and my brother and a bunch of our friends were playing laser tag in our yard. And we had these 2 big pine trees in our yard. My brother climbed all the way to the top of this tree. I mean, this tree was 100 feet tall. Okay? And so we're shooting at him up in this tree, and he slips and starts like falling out of this tree, but hitting like every branch on the way down. Okay? And we probably hit him 15, 20 times. He thuds to the ground, not that hard because he was literally hitting every single branch of this. Hits the ground, gets up, turns his thing off that was flashing because he'd been hit. Missed me, runs off. It's funny. I don't know why that came up from your.
That is weird.
Yeah, I don't know why that memory came up, but it was interesting. Okay, so certainly apply these guys to different things. Do people still play these today? Yes, but in a limited nature. What about modern game genres that MUDs have kind of influenced?
MMORPGs.
Okay, MMORPGs, that would be like the hack and slashes.
Yeah.
So, the Dungeons and Dragons, like the
Warcraft.
World of Warcraft, that's the game I play. So, Second Life, not really a game. Second Life's more of a social experiment, right? So more of the social MUDs probably lend themselves to Second Life. World of Warcraft would be the hack and slash type things. What about, so a big genre of games today that's very popular is like these first-person shooters, right? Counter-Strike and Battlefield and all those things. Is that related to a MUD? It kind of takes it a little bit different direction, but it's a shared experience with a bunch of people. How many of you have play Xbox or PlayStation or computer games, something like that? Can you even get a game today that's not online with a bunch of other people? They all have an online, they either have an online component or the only component is online.
So like stuff like Halo is
Yeah, that's a first-person shooter. You know, there's a campaign mode for Halo where you can play yourself, but a lot of people who are big time into Halo or games like that, they just skip the campaign. The campaign's just there for fluff. They want to get online and play against other people and run around and shoot people, right? That's well, I mean that has become it. And it's really funny when you watch the evolution of that. Way back when we had these shared experiences through MUDs, and then we kind of went away from it with our early video games. As graphics took over, we didn't have the ability to take those games and connect them to other people. We didn't have the technology. So we had games like Super Mario Brothers, stuff like that, which were, you know, hugely popular, right? You know, but these games weren't online. And then you had a whole bunch of sequels to the Mario Brothers games. They weren't online. You know, now there's some aspects of those games that are. You know, I think the latest Mario Kart supported an online thing where you can race against friends who were not in the same room as you. You know, but Nintendo has always kind of stuck to that whole party game idea. You know, hook 8 controllers up, you're in your living room, and you're racing everybody in the living room. Okay? But, you know, PlayStation, things like that, you know, you take a game like Battlefield, there really isn't a game unless you're online with 100 other people.
So it's by chance when you play it.
Say this again?
I said, so when you play it, it's by chance.
I guess to some extent. You know, either you're relying on the fact that a lot of other people are playing at the same time, but certainly, if you were the only one on, you got nothing to do. Realistically, the bigger risk is the servers are down. So, for instance, when Battlefield for PlayStation 4 first came out, they were having a bunch of problems with the PlayStation Network servers. So you had 100,000 people all wanting to play Battlefield. None of them could connect into the game. So you all had a $70 game that didn't do anything. Another example, this just happened yesterday. A new version of Halo came out called the Master Chief Collection, I think, for Xbox. I think for PlayStation. Well, no, I think it was Xbox. It's Xbox only. It's an Xbox only game. But it came out, and the match play didn't work. You could play the single-player campaign, which nobody wants to play, but you couldn't play the online version with all these other people. Something was wrong with the servers. They didn't test it good enough, or they weren't able to test it under a live scenario. You know, when software comes out, there's usually like a beta test. So you have a private beta. Maybe you have 1,000 people participating in the beta, which sounds like a lot, but when you talk about a game like Halo, 1,000 people is nothing, right? When you have a live server, you're going to have hundreds of thousands of people trying to connect it all at the same time. It's going to be interesting. I'll report back next week, but I'll make a prediction. So, like I said, I'm a big World of Warcraft player. I've been playing for a decade. I've quit about 7 times in there, but I keep coming back. But in any case, the new expansion comes out at 2 a.m. tonight, tomorrow, however you want to think about it. So I'm going to set my alarm. I'm going to get up at 2 a.m. to play. Well, I fully expect that there's going to be a bunch of server problems, probably between 2 a.m. and 4 a.m., where I might as well have just slept until 4 a.m. and got up. Because everybody's going to be fighting to get into this game, and there was no way for the game developer to test for that amount of people connecting to the server and that kind of stuff. The hope would be that Blizzard, the people who make World of Warcraft, will do a little bit better job because they've had a decade of experience with it. But Halo's been around for a while too, and their game was basically unplayable yesterday. So kind of an interesting thing, but we've seen these technologies evolve. And that's the point. And really every single game that we deal with today, every game, has an online component or is strictly online. So it all kind of started with this idea of a MUD, and then evolved from there. Okay. So anything else you want to add about the MUD paper? Okay. So let's go and look at our homework assignment, which was to take our cave crawler, kind of our start of a MUD. So update our crawler game to allow the user to traverse through the cave, walk through the dungeon, if you will. Okay. They should be prompted in each room to pick an exit or quit. Every room they enter that has a treasure, they should earn 1 point. Okay, so remember last time we randomly selected whether a room would have a treasure or not, right? So some rooms have treasures, some rooms don't. As you walk through rooms that have treasures, you should pick up the treasure and earn a point for the treasure that you picked up. Let's see. Once they quit, so when they finally decide I'm done, they stop exiting and stuff like that, the total number of treasures collected should be displayed to the screen. You should also display the total number of rooms visited. So every single time they visit a room, we need to keep track of that. Take an exit, visit a room, however you want to keep track of it. You do not need to let them start over. And you cannot move backwards in the cave. So basically they get one shot. They keep picking their exits until they finally either get to the end and have nowhere else to go or choose to quit. Make sense? All right. So let's go into our code here. Do I? No. I did run a software update on it earlier. It's possible to just update it to the newer version.
I still have to do
I don't. No. The only reason I did it is for that error message that just popped up there related to Android stuff. So typically I don't. I reinstall Eclipse once a year or something, just whenever I wipe my computer, get a new laptop or whatever, something along those lines. Let's see. Ours was not called Crawler, right?
Yes, it was.
Are you sure?
Yep.
So I have a couple of versions of this on here. You're thinking this is from this last week?
Maybe.
I don't think so.
No, because you didn't have JSON.
Yeah, that's an old one. That's foreshadowing. That's showing you where we're going. Okay, 537. Here we go. 537 Fall 2014 Crawler. Okay, so I'm just going to open all these for right now. So, inside of our driver, we create our cave, and we tell our cave to display itself. What does a cave do? Well, the constructor for a cave creates a brand new room, which is the entrance of this cave. So this is kind of a, we're kind of branching off this idea of a linked list and moving more into the idea of an n-ary tree. We mentioned that last time, right? The idea of an n-ary tree. So a tree that has, where every node has 0 or more children. Okay? So the cave will keep track of the root node of the tree. So this, we can say as a synonym, our cave data structure here is a tree. And the tree has a single root node. In this case, our root node is a room. So we'll set the entrance to a new room, calling our room constructor. And it just so happens our room constructor potentially creates new rooms over and over again. So looking quickly at the room constructor, when a room is created, we inform our global stats class that has a number of rooms in it that rooms were just created. Num rooms plus plus. Then each room has a linked list of other rooms. Okay, so I showed you last time how to use Java's built-in linked list class with this thing called generics, so we can hold specific objects like rooms. Then we're going to randomly generate some values, so we get our random class, an instance of random class for randomly generating values. We determine, does this guy have a treasure or not, by rolling a random boolean, either a true or a false, from this line right here. If it has a treasure, we'll increment the number of treasures across our entire cave. Then we're going to decide how many exits does this particular room have. 0, 1, or 2 exits, right? Well, yes, 0, 1, or 2 exits. Then we'll go through the number of exits, and for every exit we're supposed to have, we're going to generate a new room and add that room to this particular room's linked list of rooms. All right? So this generates the new rooms. And each of those rooms then goes through the same spiel. Make sense? And then we just kind of rely on pure chance for the cave to finish. At some point in there, it should exit, die a natural death, I suppose. All right. Now, back in driver, we tell our cave to display itself. And all display does is it goes to the entrance. And the entrance displays itself. What does that mean? The entrance is a room. So go into room, and here's the display method for room. Shows us the obvious exits. So it loops through each exit that's in there and prints out, so if there's 2 exits, we'd have 0 and 1. Correct? As our obvious exits. And we put a little tab in between each one. That's what this \T is for. Then we say whether or not there's a treasure in this room. And then we put this nice little pretty extra line at the end. So if we actually run this, here's our number. Oh, bad example, but here, let's run it again. Let's run it again. There we go. All right. So number of rooms 6, number of treasures 1. That's in the entire cave. So here's the room we're currently in. We have obvious exits. We only have 1 exit, and that's direction 0, whatever that is. And this particular room we're standing in does not have a treasure. So our job for this homework assignment was give us the ability to walk through our cave. That is, take this exit. Okay? So we need to be able to prompt them. What do we want to be able to do? If we go back to our set here, what's the name of our variable real quick? Cave. It's called the entrance. So we go back here, we have a variable called the entrance. Oh, come on. You got this. Okay, and the entrance relates to, I'll just draw a little arrow. Is a variable inside of our top level cave object that points to the very beginning of our cave. Okay, so at that level, we only know about this. Now, when we say we're going to traverse the cave, somebody's going to be given an option. What would you like to do? So we want to visualize ourselves standing in this room and being prompted to, what would you like to do? So in this cave example, we have a bunch of rooms. Room number 1 here, the cave entrance has 2 exits, 0 and 1, right? So it's going to ask us, what would you like to do? And let's say we choose 0. So that means we'd like to go from this room to this room. What does it mean to go from this room to this room? Well, in real life, we think about that. If I leave this room and go into that room, I see new surroundings. Okay? So we have to think about, how do we give a human perspective to this? When you look at the running of this right now, we're going to say our human perspective is through this screen. We're looking into this room. This is the room we're in. If I press 0 to go into a new room, now I'm going to be looking at a new room. How do we mimic that perception of what room we're in? Do we actually put the user in the room? Well, if we think about, if we're implementing this like real life, are we all in this room? So we're in a mud, right? So we just all happen to be congregating here in this room with our tea kettles and made up coffee. I did finish the coffee and the tea, by the way. Wash that down with some Mountain Dew, and I want to gargle.
Was something normal?
I like the tea.
It was coffee.
No, coffee was interesting. Okay, so if we're trying to solve this problem as like real life, we want to think about this as who else is in this room, right? Well, right now our game doesn't support having multiple players. It supports having one player. So there's one perspective. And who is our one player right now?
The user.
The screen, right? Our interface with the user is through the computer screen. System.out. Systemed out prints out to our user. So that's where the user is. Okay? So right now a room is a collection of other rooms and a treasure. Okay? Now, let's just create the concept of a player. Initially, we're just going to have one player. Let's go ahead and create the concept of a player. So I'll create a new class here. We're going to create a class called a player. Now, for our perspective, let's just write the, before I even do that. From our perspective, what's a player in this game right now? Okay, it's not a hack and slash or anything like that. A player has a position in the cave. So a player is associated with a particular room. Fair enough? So a player is associated with a current room. And we'll just write a quick little constructor for player. It does nothing. That would have been given for us, but we might add to it here in a little bit. Okay. So that's our cur room. Somewhere in here, and let's go ahead and make this private. Somewhere in here, we need to have the ability to set our current room, right? So that our current room becomes something different. Remember, when we first enter our cave, we're going to set this player's current room to the room he's currently in. Room I'm currently seeing. Okay? So that'll be the entrance. So we're going to go ahead, we're going to have a public void set cur room. This guy will take a room R as a parameter, and we'll set this dot cur room equal to R. Okay? So take this one little step at a time. So now we're bringing a player into the mix here. Go back up to the cave level. Okay, so when a cave is created, this is what the cave looks like. Now, we need to have the ability to enter the cave. For no good reason other than setting that player's cur room to that entrance. Kind of get the ball rolling, right? All right. So, we'll say enter, taking a player P, and player, so P dot set cur room will be equal to this dot the entrance initially. Right? All right. Then we probably want, well, first of all, notice what happens here. When we call display on our cave, what does the cave do? It displays the entrance. Well, could we ask a player to look around? So we're just going to change some wording here, right? So if we walk into the cave, we're going to look around, aren't we? See what's around us. So we're asking the room that we're in to display itself to us. Kind of make sense? That's the act of looking around, but we're going to just give some different words to it. So go back to player here. Now I'm going to write a little method here called public void look around. From a player's perspective, looking around says, whatever room I'm currently in, I want it to display itself. So this dot cur room dot display. That's what look around means. Make sense?
What the heck is that supposed to return?
Nothing. It's void.
Oh, okay.
But display, so it's not returning anything. We're asking the room to display itself.
Well, I mean, like, we don't have a display method
Yes, we do.
inside of
Right here.
cur room. I mean, inside of.
This is room.
That's what it's going to display.
Yep. It's going to display. This guy's a room. Cur room is one of these guys.
Oh,
So this is to display the current room the player's in.
Gotcha.
All right. So when we enter a room, We'll go ahead and set that room to that entrance. And that happens at the player's level. So we just set the current room. And when we set the room, we probably want to go ahead and automatically look around. This dot, look around. Okay, I just walked into a new room. Naturally, we're going to look around at least once. Later on, when the game starts evolving, where at any point in time, some things might come into the room, some things might leave the room, that kind of stuff, we might want to look around more often, right? We might not want to rely on the one default time. You know, maybe we don't remember is so-and-so in this room. You know, because when you start getting into, you know, multiplayer games, you have people coming and going all the time. Then you also have, you know, monsters or non-player characters, computer-controlled stuff coming and going as well. So there might be 40 or 50 or 60 things in a room at a time, and you might not remember all those things from the last time you looked at the room, looked around. Okay? So, by default, when we get our room set to a new room, we're going to go ahead and look around. So back in Cave, we have this idea of entering a room at the cave level. So we're entering the cave. And we're going to go ahead and take away a cave's ability to display itself. Okay, we're going to say that no longer makes sense. Caves are inanimate. It's a player that experiences the cave through their eyes. Okay? We're really using the same tools. We're just kind of building this in an object-oriented way and thinking about it from a player's perspective, the person who's going to traverse the cave. All right? So now, so we just created a new cave. Okay, God made the cave. Now, we need a player. The player is equal to a new player. Then we're going to let the player enter the cave. That make sense? Yeah. So now, when we hit play here, we see we pretty much get the same output we had before. But the means by which we got it was a little different. Kind of a little more, let's say, realistic. Kind of fits our idea of what's going on here a little bit better. All right, so now the player is in the room. And we just looked around. So let's go back to the player's perspective. We just looked around. Now, if we just walk into the room and we look around the room, the next thing we're probably going to ask ourselves, what should I do next? Right? That's the thought that goes through our mind. The player's mind asks that question. So, we're going to write a little function in here. Make it private at first. Let's call this display menu. So for right now, we'll just say, what would you like to do? Just as a little starting point. After we look around, looking around says display the current room, and then display the menu. Okay? Player walks into the room, they see the room, they look around, see the room, and now they ask themselves, what should I do?
Well, they're trapped, so they can't do anything.
In this particular, well, no, they're not trapped.
Yeah, 0 exits.
No, there's one exit. That's 0.
Oh.
0 or 1. Yeah. All right, so this is going to ask us what we'd like to do. Now, we want to actually be able to read crap in. Yeah, from the user. So when we say what would we like to do, by the assignment, we're supposed to allow them to do one of two things. Pick an exit to take or quit. Right? So we'll put that in parentheses here. Choose an exit or quit. All right, that'll be good enough. We'll just assume we know the rules of what to type in. So we're prompting them from that. Now we need to give them the ability to enter something. Now notice just real quick, our obvious exits are already placed here. So we already see what the possible exits are, 0 or 1. Okay? So we need to now actually read it in. So when I prompt them for this, I'm actually going to do it as a print instead of a println. So we'll read it in all on one line. Now we're going to create our scanner. Now, realistically, we probably only want to have to create the scanner once. That's our input between the user and the system. So what we'll probably do is have a private variable at the top of type scanner called player link. It's kind of giving some video gamey type terms to it, right? So this guy's going to be called player link, and we've got to import java.util for this to work. And then in our constructor for player, we will create that link between the game and the player. Okay? So we'll say, what happened? Did I not? You got this. All right. So we'll say this dot player link is equal to a new scanner system.in. All right. So now we essentially link to the player. We have a way of reading in from the player. We already know how to write out to the player through system.out. Correct? Realistically, if we take this a step farther and we start making this an online game, we might create a class called PlayerLink that has both the ability to read from and write to the player, rather than just assuming the player is local and all writing happens through system.out. That way, if we were writing to them over a socket connection, which is a networking kind of a established connection over the internet, we would write out over that socket rather than system.out, which is just a local monitor. But for right now, this is good enough for us. All right, so player link. Actually, I want to name this player input link, just to kind of go along with what I just mentioned. All right. Now, down here in display menu, what would you like to do? We're asking them a question. Now we actually need to read in their answer. So that's going to read in the player's choice. Correct? All right. Now we have some decisions to make. Well, what did they choose to do? Well, initially, let's just give their only option is taking exits. All right. We'll deal with the quit later because the quit's going to have to display some statistics about their game experience, right? And we haven't really been keeping track of that yet. We'll do that as we start working through the cave. So we're going to basically assume whatever they entered in right now is a number. Okay. And for right now, we can also assume it's a legal number. All right. So the answer will be a number. It'll either be a 0 or a 1 or nothing if there was no exit. But for right now, we're just going to assume there was at least one exit. All right. So if I have the answer and the answer is currently a 0, what room do I want to take? So if I've displayed it and I'm going to take exit 0, my new room becomes whatever room is on the other side of that door, right? Okay. How do I get that room? I'm currently a player. So if so here we'll just write a kind of a hard-coded if statement. If the answer dot equals 0, this might not be the best way of doing it, but just hard-code it for right now. If I chose to take the first exit, first room, then I want to make this player's cur room be equal to that room. Okay. So you want me to call the player's method set current room? All right. So we'll say this dot set current room. And what room am I going to set it to? What's the answer? The answer is just the string 0. Okay. So who knows about that next room? player's link to the cave is through the current room they're in. So they have to ask the current room to get them exit with this number. That makes sense? Get me exit 0. Get me exit 1. So we need to build into room the ability to get other rooms. So we'll go back to room. Public room get. Call it get room exit. And this guy's going to take an int pos, so the position of the exit that you want. Ooh. All right. Now, again, for right now, let's just assume pos is a legal exit. Okay, we're not allowed to give it illegal input yet. All right, so we're going to say it pauses, it must be legal. Remember, room has a collection of rooms. So we want to return the room at position pos. So that's how we get a room at a particular position in this linked list.
And that's just a Java function to get.
Well, it's a linked list function. Yeah, linked list function in Java. So this says, go to my linked list of rooms, get the room at position pos, and go ahead and return that room as a room from the get room exit method. So now we can go to player, and now player has the ability to ask their current room to get them the room that an exit leads to. So this player is going to set their current room. Well, here, I'll write it this way first. Set current room to this dot cur room dot get room exit the answer. So the answer is a string, right? So if we need to turn it into an int, we have to parse the integer out of it so that we can pass that integer into the get room exit method so it can go and get us the room at that particular position in that room's list of rooms and return this whole thing right here boils down to an individual room, which we will then set to our current room. And when we set a room to our current room, what do? Well, we set our current room to that, and then we look around. That make sense?
Yep.
What would you like to do? Well, we have no exits in this particular one, so we're going to start over. Now we got an exit. What would you like to do? Well, let's go exit 0. Now we're in a different room. No exits in here, so we're done. Let's try it again. Yeah, a bunch of rooms in here. All right, what would you like to do? Let's go to exit 0. What would you like to do now? Let's go to exit 0. We haven't had any treasure yet, right? Oh, we only have one exit in here, 0. Still no treasure, 0. Treasure. Should have just got the point, right? We got to remember, we're going to be, as we enter a room, we need to get, mark that we just got a point. So what we're going to need to consider right now is, what does it mean from a player's perspective to enter a room? At what point does our player enter a room? Well, that's why we're going into the room. I'm talking about at what point in our code. Set room. So if I'm a player, we just asked the question, what do you want to do? Well, we're going to put in a 0. I want to go to room 0. When I do that, we're going to call that player's set room equal to his current rooms dot get exit 0. That's the point when the player transitioned from one room to another room. Okay? And that's also the point that you want to give him credit for a treasure. that make sense? That's where the look around thing comes in. So that's in set cur room. So we actually enter the room right here. We see the room right here. But we want to give ourselves credit for the treasure before we see it. Because look around does what?
It just displays the room.
Well, it displays the room, then also displays the menu, which asks for user input, which might go to a different room. So we need to make sure we get credit for our treasure before we do look around, because that might be our only opportunity to mark that we found a treasure before we leave this room. Make sense? So, set cur room, we're going to say check for treasure. That's what we're going to do. After we set our current room, we're going to look at our current room for a treasure. All right. Well, how do we find out if a room has a treasure? Well, the only one right now who knows whether a particular room has a treasure is the room itself. So let's go and look at what kind of information our room currently gives us. Well, room has a private variable called hasTreasure. So we can't access it directly, so we're going to need to write a method. So public Boolean get has treasure. And this guy will return this dot has treasure. Okay? So now a player can ask their current room, do you have a treasure? Go back to player. If this dot curroom dot get has treasure, just for redundancy purposes, so it's clear, if that's equal to true, even though this is redundant, saying equal true is identical to just saying if this dot curroom dot get has treasure. Because if this boils down to true, this Boolean expression will be true. Okay? But for right now, I'm going to leave the equal true on there. It's redundant, but it's very, very explicit. And as we're allowing this to kind of grow, I think this will be, from a educational perspective, clearer. All right, so if we do have a treasure, what do we want to do? We need to mark that somewhere. Found a treasure. Okay? Well, where's the most obvious place to keep track of treasures? Couple variables? Who knows about how many treasures they've collected? Well, we could do it there. Could certainly do it there. But let's think about this. And there's nothing wrong with that. You could do it there. So if I'm the player, and I just went from this room to this room, and I picked up a treasure, who has that treasure? I do. I have the treasure. So the object-oriented way of doing this, we're trying to mimic real life, so unless we come up with a good reason to put it up in stats. It's not wrong to put it up in stats. But from an object-oriented perspective, we might say, okay, the player collected the treasure, so I'm going to have my little collection of treasure. That makes sense? So inside the player class, we're going to have a private int num treasure. And num treasure will always start off at 0 because we have not found a treasure yet, right? Okay. So now if we did have a treasure, this dot num treasure plus plus, add a treasure. Now, if you walk into a room, so let's say you walk into this room and there's a treasure sitting on this desk up here. If you go up and you pick up that treasure and you put it into your backpack, then you immediately exit the room, you got a treasure, right? Is there still a treasure in this room? No. We just collected that treasure. We need to collect that treasure, right? So that treasure needs to get removed from the room. So how do we do that? Who knows about the treasure that was in the room?
I can't phone.
The room.
Yes.
Yeah, room knows about the treasure that was in there. Player now has a pointer to that treasure, right? Well, not even a pointer. Player has already counted their chicken, so to speak. Got a treasure. They already marked it. So now, to keep the checks and balances going, we're going to have to go in and actually physically remove that treasure from the room. Make sense? All right. So, our room knows about treasures. So we can write a method, public void remove treasure, and this guy will set this dot has treasure to false. Right? Okay. Now, we could actually write that as one method. We can kind of create this concept of I come into the room and I just grab the treasure. Whether there's treasure or not, I attempt to grab the treasure. If I come out with a treasure, the treasure is now gone. If I don't, no harm, no foul. Right? I just looked a little funny, swinging my arms trying to grab the treasure. Now, having said that, again, from an object-oriented perspective, we could create these two methods in one method and accomplish the same end game. I tend to like being explicit about code, especially if something you're trying. One thing I want you to kind of notice what we're doing with this program here, because this isn't a small program. You know, every minute we're working on this gets bigger and bigger and bigger and more complex. A tactic that I've learned over the years that I like to kind of share with other people is to write large programs like this. Never write more than what you need right then. So I kind of let these projects grow. All right. We could have gone into player or room and written a whole lot of other functions that we think we might need later. But I would be an advocate of not doing that. Only write what you need now and write those other pieces when you need them. Okay, because you're going to know more about it then than you do now. Okay? So, having said that, I think it makes a lot of sense to ask a room, is there a treasure? Then remove the treasure if there is. Having said that, the name of this method, this get has treasure, is very much a computer programmer type of name. You know, it's like they're called getters. You know, I might change the name of this method to is there a treasure? Okay, is there a treasure? Method's going to do the exact same thing. I just changed its name. So now back in player, now it maybe makes some clear sense to take the true off. If the current room I am in, is there a treasure in that room? If there is, count the treasure. Well, before I count it, I'm going to say this dot current room dot remove treasure. That makes sense?
Yeah.
Then I'll count that I just removed a treasure. Okay? So, do you see how this kind of reads pretty clearly? So if you came back to this later, it's pretty clear what this means, what's going on right here. Okay? That doesn't mean you couldn't have written it in a more cryptic way. But I kind of like code that self-documents itself, and I don't think there's anything wrong with that. Some of you are going to be more advanced programmers, so don't worry on your assignments. I can read your code. So if you didn't do it the way that's fine. You know, like I know a couple of you guys have programmed a lot. I know he's programmed a lot. So, you know, if you didn't take the baby step methods that I do, it's not a big deal. You're not going to lose points. Correct is correct. I'm okay with that. I'm just kind of showing you a way that I think makes a lot of sense. He's taken a couple of the undergrad classes with me, but it's more just he needs to get credit for them. He doesn't need the content. He knows it already. So my policy in my classes is you're not allowed to use stuff until I've introduced them. But he knows a bunch of stuff that hasn't been introduced, so he's like, you're trying to keep track of what do I know and what am I supposed to know. No, it's a thing.
That was a hard concept last year.
It's always a bigger issue for truly beginning programming students who go and get their answers from Google. You know, because then they're going to use stuff that the people on Google knew about, not them.
Right.
I can tell that like he has had this stuff before, so it's not a big deal. But usually there's a rhyme to my madness. There's a reason to my madness.
We know this.
I want you to do it the hard way first, and then I show you the easy way.
So we can be mad.
What's up?
I said, so we can be mad
Yeah, but how could you be mad at me?
for making this political.
But I'm so funny.
That's true.
Don't I bring computer science to life?
You do. But
I mean, this class could be way more boring than this.
oh, I know. And I appreciate how funny it is.
No, I don't think you do.
I think I do.
Did you bring me tea?
No.
Did you bring me weird coffee?
No.
Did you put weird stuff in my tea?
No. Because I like you, I wouldn't do that.
Are you still handing out Halloween candy? And then last week, Habib didn't even bring me my Portillo's.
He didn't do it this week either.
You know?
Yeah, I
You-
already talked to him. He said maybe next week. Sorry to be very bad news, but
I see how his motivation changes when I'm no longer in control of his grade.
oh yeah.
Yeah.
He said that he was like, oh yeah, I would retake the class just to get a better grade, and then keep bringing you Portillo's. So I was
I
like,
mean, I offered to pay for it. Just bring me my food from Chicago. All right.
it was good, though.
Oh, I love Portillo's. That's where my wife and I stop. If we are in somewhat of a rush. My folks live in downstate Illinois, Champaign.
Okay.
So I grew up in Illinois, but downstate, not in Chicago. But we go through Chicago to get there. So we always stop. We either stop at a place that's, they have two locations. One of them's near Midway Airport called Chuck's Southern Comfort. It's a barbecue place, really good. So if we have like an hour or something like that to kill, we'll go there. But if we're kind of in a rush, but we just want to break up the trip, we stop at Portillo's, which is, a 20-minute type of ordeal. But
I wanna go down to Chicago, but that's for
love Portillo's. If you've never had Chuck's Southern Comfort,
No.
when you're off your fast, go and hit that hard.
We'll see, I'm trying. Okay. All right. I have to go down.
Trust me on this one.
Making me day trips down to Chicago just for food.
All right. So in any case, when we set our room, when we first enter a room, we'll remind ourselves the room we're now in. We'll ask, does this room have a treasure? If it does, we'll remove the treasure. Then we'll count the treasure. And then we'll look around. Okay, but then potentially go to the next room, whatever. All right. Now, we're also supposed to keep track of the number of rooms we've entered.
Yep.
Correct?
Yep.
So, again, who's going to know about that? Probably our player. I know how many rooms I've entered. I know how many treasures I've picked up. Okay? So we'll set our num rooms equal to 0. Give ourselves a... I'm still burping up that coffee.
This is tea, but with no weird things.
Huh? Tea was pretty normal. Is this the other tea?
Yeah. But this is just clear.
It's clear tea.
Clear tea.
What?
The other tea looked clear to me.
I mean,
Well, that was the something.
other thing was- yeah. One more on the clear one.
Yeah, I'll try the clear one.
They trying to kill you. No, I'm just playing.
Well, it's too late now. I've already had a bunch of it, so I might as well.
Oh my goodness.
This looks the same. Are you sure I didn't have this before?
This is doesn't have anything or everything. That is.
Anything or everything? I
Well,
can't tell if that's bad English or just trying to be funny. Anything or everything.
That's horrible.
Don't you like eating cultural food?
I do. I love Italian food
Well, that's just one culture.
and Mexican food
It's a couple cultures.
and soul food.
Would you eat some of their food?
I think I have before. Yeah.
It's good stuff.
Yeah. It was good.
I mean, they take their seasoning seriously.
I know.
Love
My
that.
friend made some for me.
Americans, we just throw sauce on it.
Too.
we just throw sauce on it. It's good to go. All right, so we're going to keep track of our number of rooms. Every single time we enter a room, okay, whenever we set our current room,
So then we do
well, here, just
after, right?
we just entered a room. So we'll say this dot num rooms plus plus. Make sense?
Did you ever use that before? I wasn't. Never mind.
I don't think so.
Okay.
Okay, so we'll set the room. We recognize the fact that we just entered a room, so let's go ahead and count it. We'll check, is there a treasure? If there was, we'll collect it and count it. Then we're going to look around. See, kind of tells the story for us, right? All right. So we look around, we ask the same question, process our decision, rinse, lather, repeat. All right. So right now, we're doing this if the answer is equal to 0. So we're never allowed to take exits 1s right now. So if we go back into this, so I have a 0 or 1. If I press a 1 here, nothing happens. Doesn't know how to process a 1. We only know how to process a 0. Realistically, for our options here, we're either going to have the word quit or a number. Correct? So what I could do is I could just ask if they said quit, then let's quit. Let's do whatever it means to quit. Otherwise, let's just take whatever they entered, turn it into its number, and take that exit. Again, we're assuming the number was a legitimate number, a real exit. Okay, so what we're going to do here, I'm just going to steal this line for a second. We'll put that back in here in a second. So if the answer is equal to quit, do the stuff that means quit. Else, we're going to do this. We'll set our current room to whatever room that exit that we entered leads to. Okay? So we haven't written the stuff that means quit yet, but now we support multiple exits. Okay? So we're either going to quit or we'll take the exit we requested.
In this case, if you type quit,
It'll go in here and do nothing.
okay.
Yeah, do nothing. All right, and I have no exits. Perfect. No exits. Okay, there we go. So before, we couldn't have taken exit 1. Now we can. Hit a dead end. So now our only choice would be to quit, which we haven't written the code for yet. But that's at the point would be that we would naturally quit that. Right? Okay.
So I'm wondering if someone writes quit with capital Q, is it going to work?
Not as we have it written right now. If you want it to work, we could say if the answer equals, ignore case. There's a version of the equals method for strings that ignores case. You could also just convert the answer to lowercase and then compare it to equals in all lowercase. Same thing, not that important. We're already making assumptions that they're putting in the correct exit. So we could pretty easily crash our program. So if I run this, and let's ask me what exit I want. Let's do this again. Okay, now we have an exit in there, and I'm going to say I want to take exit 7. Okay, it's not going to be happy about that. Okay, because I just tried to access the room at bucket 7 in the rooms of the current room that only had, they only have 1 or 2 of them in this one. Only had 1 exit. So I tried to access bucket 7 of something that only had a bucket 0. Not a happy camper. Okay, so we can break our code pretty easily right now, but functionally it does what it's supposed to do. All right, now, quitting. What does it mean to quit? To quit, it means I'm done. Don't ask me to do anything else related to rooms, but I'm supposed to report number of treasures I found, the number of rooms I visited.
So you just go to the display method inside a room.
Well, display method inside a room does what? Display method inside a room shows the room.
Right, but you can also add in there your stats from the number of treasures you collected and rooms you traveled.
We could, but who knows about that stuff right now? Player?
Yeah.
Player also knows that they want to quit.
Okay, fine then.
So inside player, we might just say, okay, I'm done. I visited that many rooms. I collected that many treasures. That's what we'll do if we type in quit. Make sense? All right, so we'll know if this is working because we're going to have to keep track in our heads. We only have one room there. Let's get something substantial. 17 rooms? Okay, we're okay with that. Okay, so we just visited one room. So we're at 1. We're in the very first room. That counts. Stepped in the cave, got a room. No treasure in there yet, so we should have 1 room, 0 treasures. We'll take exit 0. Okay, 2 rooms, 0 treasure, exit 0. 3 rooms, 0 treasure, exit 0. 4 rooms, 0 treasure, exit 0. So there should be 5 rooms. I collected 3 treasures. Oh.
Oh, computer.
Tell me why.
Huh?
Huh? We collected 3 treasures. At what point did we find out that we...
Had treasures at the beginning.
Right here. We checked for treasures before we looked around.
Yeah, because look around goes right up to the next.
Correct. Look around asks the current room to show itself, right? Part of a room showing itself is displaying whether or not that room has a treasure.
Right.
Okay? But whether that room had a treasure or not, we removed it right here before we looked around. So as far as right now goes, in terms of displaying our treasures in the room, our rooms will always say we don't have a treasure. They did before we looked around, but we grabbed it real quick. That's right. That's right. So we really need to, because we probably want to show that there was a treasure in the room.
That might do some justice.
Right?
How about we put it in between in the look around method, but under the first display method? Because you're looking around.
So display the room first, showing us there was a treasure,
Right.
and then actually pick it up.
Yep.
So take this stuff right here. I think that's a good idea. All right, so now we enter the room, we give ourselves credit for entering the room, we glance around to see if there's a treasure and any exits that are in there. Here we glanced around, so we visually show the user what we just glanced at because the screen is our eyes. We check to see if there's a treasure, removing it if necessary, then we display the menu. So kind of makes maybe more sense now. We're gonna look around before we steal the treasure until we just kind of get this like 5th, 6th, 7th sense. Right? Just grab the treasure all ninja style. Okay, so now we should. So here, there's no treasure in this first room. So we visited 1 room. Let's go to 1. Visit another room. So 2 rooms, 0 treasure. 3 rooms, 0 treasure. 4 rooms, 0 treasure. Okay, at least the answer was right. All right, 4 rooms, 0 treasure. Let's try it again, make sure we're still collecting treasure. All right, so no treasures in this first room, so 0. No treasures in the second room, it's 2. Did get a treasure in the third room, so 3, 1 treasure. 4, 2 treasures. 4 rooms, 2 treasures. Okay, so does that fulfill the homework assignment?
Yep.
All right, so that's what you were to do for your homework assignment. Now, let's go through and let's put in some checks for bad input. You know, I could tell you from somebody who played these MUDs for a long time, you got very good at going to places you went to very often. Out of curiosity, anybody in here ever play a MUD? Like, actually play it for a period of time other than just check it out for this assignment? So, for example, usually when you enter the game, you might start off at the center of the main town. Okay? And let's say that there's a place that I go to, you know, remember these are hack and slash. So there's a place that I go to kill things. All right, so there's a place that I do my hunting in the game, let's say. So, and I almost kind of remember it. I probably could still type it. You know, from center of town, I would go like west, 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 north, northwest, northwest, north, north, northwest, northwest, north, north, northwest, up. And that would take me to the place where I did my hunting. So consider it from the perspective. So I've gone there a zillion times, right? When I got into the game, I wasn't even looking at the screen. I wasn't reading each screen for the exits. I knew they were there. Okay, so I would just start, putting in those exits and pressing enter between each one. So I would move really quickly through there. Well, if at some point in there I hit the wrong key, I'd rather the game not crash. Right? It's like, oops, sorry, game can't work. Yeah, I mean, MUDs were just. There was this one game I played called which one was that? I'm trying to think of that. You could be like dragons and stuff. And one of the classes you could be in the game was this thing called a chaos mage. And so in a MUD, you have the administrators who also play the game too, but they're like, the wizards. That might have been something you read about in doing your papers. You have like the administrators of the game are usually the wizards or the gods or something like that for the game. So they can, restore items or fix glitches or get you into a room that you fell out of for some reason, stuff like that. Well, this one character in the game, this one class was called a Chaos Mage, and you had a spell called Chaos Bolt. And the spell was the most powerful spell in the game, but because it was based on chaos, there was a chance that something funny would happen, there's a chance that you would kill yourself, there's a chance that you would rain down gold onto, all sorts of stuff could happen. But you also were the only class in the game that had the ability to possibly kill a wizard. Kill the main guy, just randomly, because you had that, the chaos thing. You had the ability to kill a wizard in the game. That was kind of built into the game. So the idea is that as a chaos wizard, you might go around the game looking for admins and trying to attack them. I don't know, just kind of a fun type thing. It was cool when you're 12, but unfortunately I was older than that when I did that.
No comment.
I probably still played MUDs into my 20s. How old am I? Yeah, I'm 36. Yeah, actually, so I started playing World of Warcraft when I was 26. And before that I played EverQuest. And before that I played MUDs. So EverQuest I probably played for 5 or 6 years. So maybe when I was 20 I started playing EverQuest. Then World of Warcraft took them over. And it's always funny, these games are highly addictive. So they always have funny names that get attached to them. Like EverQuest was Evercrack. World of Warcraft was World of Warcrack.
Everything got cracking.
It's supposed to be addictive, I guess. What's this?
What is your favorite game now?
Oh, it's Warcraft. Yeah, World of Warcraft. I really don't play games very much.
But yet you're waking up at 2 a.m. to play.
Well, I've been looking forward to the expansion. I came back to the game. I hadn't played in a couple of years, and I came back to the game specifically for the expansion.
What was the game last year you had to get up early and play? It was something last year.
Last year. Oh, was it? I think there was another MMO I played for a couple months last year. Elder Scrolls Online, I bet.
No, that don't even sound familiar. It was something else.
I don't know.
Maybe it was some type of toy. New toy for you.
Sounds right.
Something, probably an Apple product.
Well, yeah, I mean, maybe it was a camp out for an Apple product or wake up early to pre-order.
Probably something crazy like that.
Yeah. Yeah, with the latest iPhones, my wife and I both set an alarm, and we both were had our computers logged into the right site. We just kept hitting refresh a bunch of times to get our iPhones pre-ordered. It's a sickness.
That is a sickness.
But hey, I had a 6 Plus when I could have sold this for like $3,000. Did you have a day one?
Day 2.
Day two? Oh, that's nothing. Day two, you missed the boat. Had you pre-ordered it?
No,
You just walked into a store and got a 6 Plus?
I get in line like for an hour, and I get
You're crazy.
Where was this located?
it. Very sure.
Bayshore had a 6 Plus in stock the second day.
Dude, they're
You must have just like lucked out.
Yeah.
Because even now, places don't have 6 Pluses in stock.
No.
They must have just got like a couple in and just had it. Yeah. Huh?
Want to order online in 4 weeks.
Yeah. I mean, even places now, you just at random luck whether they have one.
So did you play the MSX games?
Which ones?
MSX.
MSX?
Yeah, this is 20 years ago.
MSX.
Not one game.
How old are you,
Many
dude?
games.
Doesn't sound familiar to me. What kind of games were they?
Many games. Thousands, hundreds games.
Okay.
This company, like years.
Yeah, that was the name of the company, MSX. I mean, it doesn't sound familiar to me. It's possible I did. What's this?
I'm gonna beat him down.
What happened? Did he try to give you some coffee?
No. No, I asked him how old he was, and he was like, "Oh, he's old." So I was like, "Really?" So I kept looking at him, and then I was like, "No, he can't be." He was like, "Oh yeah, they're the same age." And I'm like, "Nah, that's got to be a lie." He was
Are you in
like,
your
"Yeah, it's
30s?
a lie." No,
How old are you?
I was 30.
You're 30?
Around.
Around 30?
Yeah.
well, how old are you? Stop playing games.
Oh, are you older than me?
33.
You're 33? Yeah, see, I'm still a little. There was a long time, because I've been teaching, this is my 16th year teaching. There was a long time that I had many students that were older than me, especially in my grad classes.
That's funny.
I learned it from bachelor degree 2004.
That's when you got your bachelor's degree?
In 2004. Oh,
Years ago.
Let's see.
graduating from middle school.
You graduated from.
Middle school.
I got my bachelor's degree in.
You got yours when you were like 4 years old, anyway.
I got my bachelor's when I was 16.
Exactly, infant.
I,
You don't even count. You're not even normal. That doesn't count.
I had a PhD at 22.
My point is not normal.
Well, everybody's got their thing. I got some brain stuff.
You're like Sheldon.
It's true. I actually have the same. I have Asperger's syndrome, which is what he has.
Oh, really?
Mhm. Yeah. Although, well, you didn't have me before, but definitely the last like 6 weeks or something, since I've been having some of these health issues, I've like always in a brain fog. I'm not as I mean, I'm sharper than you, but that's not saying a lot. Yeah.
Really?
Yeah, I mean,
You know what?
you expect over the years you become less sharp, right? So I mean, I'm not expecting to be maybe as quick as I was at 22. But that's kind of always been my I guess my thing is I'm very quick at doing things and don't make a lot of mistakes. The last 6 weeks, I'm in these little brain fogs. I get confused sometimes, and I got to rely on him to fix my crap in class. Good thing somebody knows what they're doing. Yeah, so hopefully these doctors get to the end of it before I just go to complete vegetable lasagna.
Stop talking about food.
All right, so we decided we were going to do some error checking, right? All right, so let's go into our menu. So this is the point where we're reading crap in, right? So right here is the line we actually read something in. Our allowable inputs are either the word quit or a number, and that number must be between 0 and, well, must be one of the rooms that are in our, that's in our current room, right? So it could be 0, could be 0 or 1 in our current setup. Now, what I want to do here, well, let's check for the quit first. All right. So if the answer is equal to quit, we do this. Else, if what they entered is a legal room. Okay. So else if what they entered was a number. We'll start off with that. Did they enter a number? Then we'll deal with whether or not it was a legal number. Make sense? So we have a couple different ways. We can write a quick method for checking to see if something is a number or not. Couple of ways we could do this. Actually, let me just ask you. If you were checking, so we have a string, and the string doesn't hold the word quit. It might hold a number. Okay, but for our intents and purposes, the only two legal situations are it holds the string quit or it holds a number. How would you check to see if it held a number? A couple of different ways we could do this. Well, a bunch of ways we could do this, actually. Any suggestions on how we would check to see if the answer holds something that is a number? Not a legal number, just a number. Well, not a legal number from a which room perspective, but it holds some number. How could you do that?
Can use method that.
Huh?
Use a method to change the percentages.
Okay.
Okay. I'm using tie catch.
Okay. So we can try to convert it into an int. And if something bad happens, then we can, say, oh, this wasn't a number. Correct? All right. Anybody else have a suggestion? I think that's a good one.
You can see the ASCII values of the string, but you should change the character, I think.
Okay.
See the range of.
Oh, I see. So you can spin through it and make sure every digit of the string is a number?
Yeah.
Okay. Doing it that way, we also have a method in the character class asking isDigit. So the character class has a class method called isDigit that allows us to say, is this single char a digit? Is it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9? So one of those guys. Okay. Well, let's go into the else here. And we're going to have, instead of the parse int here, we're going to have int room pause. And this guy is going to be equal to integer.parseInt the answer. And we'll try to go to room pause.
Don't forget the semicolon factor.
Oh, thank you. I was testing you. You passed, sort of.
Sort of.
All right, so this is what we'd like to do. We'd like to parse the number out of that guy and then go ahead and move to room pause. But, as he pointed out, we're going to go ahead and try to do that. And then catch an exception if something bad happens. All right, so we'll try to do that. If something bad happens, what are we going to do? Well, we're going to have an exception. We're probably going to go ahead and say that is not a number. Okay? So we can catch the specific exception that gets thrown, but we happen to know that the only thing that can happen in there is that it wasn't a number. Okay? So we'll go ahead and print out system.out.println. You must enter a valid room number or type quit. All right. Now, so we've given them an error. What should happen next? They tried to enter something in. It didn't work out.
Call the method again.
Yeah, display the menu. So this dot display menu. So they messed up. We're going to display the menu again. Perfect. How do we display the menu? We call display menu. All right. So it's a recursive call. But this is a pretty free recursive call because we are technically storing stuff here, but we're not relying on this guy ever returning. Okay? We're not relying on its value from this because this guy's a void. All right, so that's what we'll do if we didn't get a value. Otherwise, if we're still kicking here, room pause is a room. Correct?
Yeah, but
Okay.
is it now in the range?
Now is it a legitimate room? All right, so we're going to try to get the room exit. So we're going to say room, the next room is equal to the room we'd like to go to. All right. And then we're going to set cur room to the next room if something good happens. But we're going to have to check this guy. So we're going to look at the next room. Well, in order to look at that, we're going to go to get room exit inside of room. So right now, get room exit takes in a pause and just haphazardly tries to get the room from that pause. We could check to make sure pause was a legal position in here first, right? So if pause is less than this dot, the rooms dot size, that is the number of rooms we have in there. If it's less than that, we're cool doing this. Otherwise, why don't we just return null? You asked me for a bad room, I'm going to give you a bad room. Okay? So, that means if this guy returns null, that means the room wasn't there. Now, having said that, we now need to remember that null means bad room. Good object-oriented programming would probably have us put another method in here. Okay? So we might say public Boolean is legal room int pause. Put that in parentheses for no good reason. So we're going to have a method called isLegalRoom that we pass the pause to, and it returns true if it is a legal room and false otherwise. So we won't even try to get a room that is an illegal room. We'll only get legal rooms. So we'll ask first, is this guy a legal room? If it is, let's go ahead and get that room. Make sense? All right, so it'll be a two-step process. Now, these methods, the get room exit, became simpler, but we're going to rely on us knowing that we're only going to ever call that method if we have first called this method. That make sense? So that does rely on us knowing how our code works, but it also is going to read pretty easily. Okay? So back here in player, we'll get the room pause. We'll say if this dot cur room dot is legal room room pause. If that's a true statement, then we didn't actually need this extra variable, but we'll keep it. We'll go ahead and grab the room in a variable called the next room, and then we'll set our room to that. Else, same error message, right?
Yep.
Okay, so since we're calling that error message in multiple places,
Should we display the menu again?
huh?
Should we display the menu?
We will. Yeah, we will display the menu again. But since we are calling that error message in multiple places, and since we probably can foreshadow and see that we're probably going to make our game more complex, why don't we go ahead and have a display error method that if we do need to show an error, since we seemingly are showing the same error every time of what legal input is, we can just change it in one place and then all places that call it.
So is that going to be faster?
Not just faster, probably more accurate. Because let's just say in the end, we're showing that error message 10 times.
Right.
Well, if we're showing it in 10 different places, if we change the nature of our program, we have to now fix that error message in 10 places. Or we can write it in one place and have all of them call that one place. And then we only have to fix it in one place. Make sense?
Yeah.
So we're going to have a little method in here called private void display error. We'll just assume there's only one kind of error in our game right now. And that guy is going to have that line in it.
Actually, both, right? Did we-
They are the same line. They both were the identical line.
No, I'm saying the display menu line too, because you're always gonna call back to the menu, right?
So aren't you going to
As far as right now goes, that's true.
Okay.
So I think that's a good suggestion, rather than calling it in two separate places. So I think that's legit. I think that's legit. So whenever we display an input error, we'll go ahead and tell them the error and then go ahead and show them the menu again so they have another shot at it. All right. This allows us then in here to say this dot display input error, and also in here this dot display input error, which will then show them the error message and show them the menu again. Make sense? I think that's a good suggestion. Okay, so that cleans that up. So now we should only support legal input, is the idea here. So go ahead and run this. So number of rooms is 2, blah, blah, blah. Let's go ahead and hit a 7. Should scream at me, you must enter a valid room number or type quit. What would you like to do? Now, we displayed the menu, but shouldn't we see the room again to remind us? If we keep putting in bad input here, we eventually have lost track of our room contents.
call the method display method?
So what we can do is we can call look around. Is look around going to break because we might get another treasure?
No.
No, we've already removed the treasure if there was one, right?
Right. But on top of it, we can take out the display menu now.
Yep. So instead of saying display menu here, we'll just tell ourselves to look around again. Make sense? All right. So here we'll put in a 7. So we're getting a new copy of everything each time through, right? Okay. Now, another thing you might choose to do is you might choose to put a whole bunch of white space to kind of clear the screen. Actually, I'm trying to remember, is there something built in? I don't think there's something built in to system it out. So let's say for look around, we might say, no, let me do something here quick. System out. No, it's not. Probably not the best way of doing it, but since we're doing a text-based game anyways, where performance isn't high on our priority list. So this just kicks it down a line. Same thing as doing that, printing out the empty string.
So it's gonna kick out 100.
spaces, 100 carriage returns. But actually just saying systems.out.println like that without giving it the empty string to print will be more efficient. It deals with a different type of IO system call for kicking it down. So if we are trying to be efficient, printing out 100 things we're not going to feel. But in any case, this will basically just press enter 100 times and then display the current room.
So if we didn't do it 100 times, but still just displayed the print len, wouldn't that just give us one blank line break and then we can go on to the next instead of 100?
Yeah, I mean, it would just put one line break, but it wouldn't clear the screen, so we'd still see all the fluff from up above. Okay, but we're actually going to see a problem with this. So we'll do it right off the bat. So we'll start our game. Got our 100 spaces, whatever. Haven't hit the problem yet. Here's the problem. I'm going to put a 7 in as our answer. Never saw my error message. Scrolled right past the error message. Okay, so this becomes one of those challenges when you think about these old games, these text-based games, making the game board, if you will, make sense becomes problematic. Okay, because you're working with a canvas that's very limiting, right? You know, so in doing your research for these MUDs, you probably saw some of those transitionary ones where they started using ANSI graphics, ANSI. You see that anywhere in your research? Okay, so they started trying to transition from being a only text-based game to having some graphic crap in them. Kind of the early places that you'd see that was like in maps. So when you went to look at the map, it would give you some sort of 8-bit, probably less than that, probably a 4-bit map color map of what the map looked like. So you'd have green where there was trees, you'd have, you know, things like that, but it tried to give you some sort of visual, where before that everything was text. All right, so for our intents and purposes, we're not going to do that spacing. We'll just deal with them all running together because we're not going to make a huge priority about it, but we saw that we lose track of our error messages doing that, which actually becomes problematic because we do need to be able to deliver error messages. Make sense? All right. So, now we can put in 7 a bunch of times and we're still functional. Okay? We'll put in a 0 a couple of times. Now we're here. We'll put in a quit. Okay, I'm done. I visited 3 rooms. I collected 2 treasures. Great. Okay, so what should happen next in our cave? Okay, well, maybe get to the end of the cave. But as doing your research, we dealt with, I mean, you were looking into MUDs. These were games, or at least some sort of experience that applied to a problem, right? Right now we have kind of a traversable cave, but we're not applying it to any problem. So we could maybe turn this into a game of some type, correct? Okay. Now, for us, what might a game look like?
Ask the users how many users you would like to play.
Okay, well,
Or
down the line, definitely.
Multiple.
But for a single player. So we have our game, we're the only guy, we have no internet connectivity type thing.
probably he is interested to play a game.
Well, but we need to play the first time. What's the game going to be like? What game could we have out of this?
We can have an adventure game.
Okay, tell me about your adventure game. Okay. We want to talk about a little jump.
Map.
Well, right now our caves are random in size, correct? So if we thought about what's the smallest cave that's big enough to be meaningful for our game? Maybe 4 rooms? Just say 4 rooms. Okay? So if we created a 4-room cave, and that cave had the random treasures in it, and your goal was to capture all of the treasures. And once you captured all the treasures from that 4-room cave, you could move on to a 5-room cave. Or maybe it's an 8-room cave. Maybe you just keep doubling the number of rooms. Okay? So now you're on level 2, which is an 8-room cave. 8-room cave, you're going to go through, collect all the treasures. Once you collect all the treasures, now you had a number of moves, so maybe your score is related to the number of moves you made.
You advance to the next level.
You advance to the next level. So maybe your total score is related to the total number of steps you've taken, total number of rooms you've visited. So every time you visit a room right now, we're saying you visited a room, correct? So from that perspective, the higher the level you are and the smaller the number of rooms you visited, the better player you are. It's the concept, right? If you can get to level 10 visiting the minimal amount of rooms, then you did really well. In our world here, it's going to be luck, it's guesswork to some extent. Okay? But right now we have this tree structure that looks something like this. All right? So this tree structure is going to have you go down. So let's just say the cave we generated looked like this. Okay? Cave we generated looks like this. And we're going to go down through this cave. But let's say we right off the bat chose this path. Then we chose this path. Then we chose this path. Well, we haven't beat this level. Presuming there's more treasures over here. Right? So this level's still open. So if I'm here, how do I get back to do these guys?
Within the buttons.
You could travel backwards.
Okay.
Where you just came from.
Okay, you could travel backwards, but that actually takes some of the strategy out of our game. Any way you cut it, we're going to have to write some ability into this, right? Okay? Because right now, we don't know how to go back one step.
Or you can dig your own room.
Like, well, I'll just tunnel over here. We're good. But from a memory game perspective, so we'll throw a little education in here. We're gonna throw hack and slash in here eventually. Trust me. But from a memory perspective, if we had already walked down this path to here, if I had the ability to jump back to the beginning,
You have the
now you have to remember that, okay, if I'm going to go back over this way, I'm going to step here, I'm going to step here. Now you have to remember, I've already gone here. But there's another exit. This is the place I haven't gone. Remember, every single time you took a step, it counted. That make sense?
When I tried to solve this problem, I would like a linked list to memorize all the address from the memory.
Okay.
To see exactly how that moves.
Mm-hmm. But wouldn't this be a fun puzzle game just to begin with? I mean, it's like a memory game, right?
Right now, because I'm sleepy, no.
Okay, but you know what I'm saying.
Yeah.
Well, the good news is I told you we're getting out early,
Yes.
so that's a positive.
I
I'm
am.
transitioning towards that here right now.
I'm banking on it.
Okay, so we need to have the ability. So just for everybody else, I'm going to go a little bit past our normal break time because I'm going to let us out early.
Okay.
All right, so if you need to run to the bathroom or something, go ahead. But give me another 20 minutes, and then we'll probably be good. I just want to make sure I give you enough for your homework, enough work, enough stuff that you're able to do your homework. All right. So if we're here, and I want to bounce back to the very beginning, so that now you can utilize your memory that you remembered the rooms you visited to go back through here. How do we get back to this first room? Who knows about the first room? So again, sticking with our object, does the player know about our first room?
That
You can save that first room as a
Oh,
variable.
Right now, who knows about that first room right now?
Oh, the room.
The cave. Cave knows about the first room. Player knows about the room they're currently standing in. Player knows about this room. The cave itself, this guy, he knows about the entrance. Okay? So we can ask the cave for the entrance. So we can set our cur room back to the entrance, right? Well, we got a problem. We're in player.
Call cave.
Who knows about the cave?
Cave, because they're inside the cave.
The one is so
We created the cave right here.
Driver. So the driver.
We had the player enter the cave. Cave only existed right here. We need to somehow provide the cave to somebody.
The wizard.
Okay, tell me about that. So you thought you were saying something funny, but it's actually not a bad idea.
Ask me how it works. So you can create a wizard player.
Do we maybe already have that with this thing called stats?
I guess so. Yes.
Or we can create another one called, game. Something like that. It could be your wizard thing. Okay, so kind of a global dude
Yes.
that knows about the current game, the current cave.
Yes.
Okay.
The cave god.
The cave god. Okay, makes sense. So here we'll go by, since we're going to use mud names. We're going to go in here to really we should probably just use stats. Otherwise, we're going to create a whole class just for one little piece of information.
That's cool.
Stats. Cur cave is a stat, right? Okay, that's the current cave we're in. So the current cave has a number of rooms in it. It has a number of treasures, and then we're also going to have a static cave, cur cave. Make sense?
Yep.
So when we first create that cave in driver, we're going to say stats.cur cave is equal to C.
Yes.
Now, realistically, we didn't even need to create our C. We could have just said stats.curcave is our new cave. Then we create our player, and then we say stats.curcave.enter the player. What cave is the player entering? The current cave. Current cave associated with our current game. Okay? So we're transitioning, and some of you noticed the homework assignment was already up. I think I unlocked both of them last week, so it was a mistake. But if you looked at the next homework assignment, it deals with creating this, taking this a step farther towards the game. Okay? So now we're going to have the player enter the current cave. But more importantly, now we have that global object stats who has access to the current cave. So if I'm player and I want to add to my menu the ability to go back to the beginning. So what would you like to do? Choose an exit or quit.
Choose an exit, quit, or
Start.
again.
Start. Okay. Start makes sense.
Start. Because
Well,
you already started.
It's a lot to type.
And I thought I was lazy.
We can port back to the beginning. So it's a portal. It's a portal. Right?
Started.
Start's good. Okay. So now we have multiple things. So we're going to answer: did they want to quit? Ask if they wanted to quit.
Else.
Else if the answer dot equals ignore case start. That means we need to do the crap that is related to starting. So that means we can go to our cave. So that's stats.curcave. And we want to set the player's current room equal to the cave's entrance. Does a cave know how to give us the entrance at this point?
Yep. It's not entrance.
Just say enter again.
Yeah. So rather than ask the cave for their entrance, we're porting the player out into the nether. And then we're making them enter the cave again. Right? So we're going to get the cave.
This reminds me of Tomb Raider.
enter. We're going to have the player enter the cave. How do we say that? This. This keyword. This is how an object refers to themselves. I am currently in the player class. So if I say this, I'm saying, add me to the current cave. Does that make sense? Okay, so I'm passing myself through this portal, entering the current cave, which should put me right back at the beginning.
I got a question.
Yep.
So after this homework assignment is done, are we gonna have another one adding multiplayers or no?
Maybe.
I'm not
Maybe-
giving you ideas.
Maybe there'll be monsters too. All these assignments are written.
Oh, okay.
Maybe there'll be monsters too. Maybe the monsters will move from room to room.
Are we adding graphics?
Possibly. All right. But only possibly, because this little Thanksgiving thing might throw a little wrench in that. But we'll see. We'll see. Any way you cut it, it'll be cool. We'll do some neat stuff. All right. So if they entered start, we're going to go ahead and throw them at the beginning of the cave. Now that's going to count. It'll count as another room they entered, right? It's like they took a portal exit. So going back to the beginning will count as a new room, which is fine because we happen to already have it written that way. Every time we enter a room, we count that it was a room. Now, if it was our existing room, the treasure is going to already be gone if it was there.
Right.
Okay? No big deal. We'll still search for it as we look around, but we won't find a treasure. All right, so
Already have it.
correct. So now, let's go ahead and test this, although we do need to change. So choose an exit or quit or start. We need to change our error message. You must enter a valid room number or type quit or start. So again, changed it in one place. Now we know the error message will always be correct.
I believe the set method, the set current room.
This guy?
You are adding the number of room. I'm imagining the situation that the guy just entered the room, entered the cave, and then say, start.
Start when he's already there?
Yeah.
Okay.
So the room is the same.
Okay, so he's thinking, I'm right here, and now I'm going to type in start to go back to the beginning of the cave. You can start racking up the number of rooms. So maybe we only let them do that if their current room is not equal to the start?
Yeah.
Okay.
You can use -1 when you click start.
Well,
You said you don't.
yeah, you can do that, but now you've created a way for them to cheat. Okay, they can just get back to the main room. If we're gonna, every single time they call this, if we're gonna subtract 1 from their room count,
Yeah, because
Just to-
it's already the entrance.
well, right. But now he can just stand at the entrance and just sit there and keep going to the entrance, knocking his numbers down.
Oh,
He could cheat. He could cheat at the game.
Ways. But how you gonna keep knocking your numbers down if you haven't really traveled any run?
Well, if we decided he was suggesting we do a -1.
Oh.
When you do start, you subtract 1 from your number of rooms.
Mhm.
Well, so not count that portal.
We have
What
a
I'm
count
saying
for
is-
start. How many times
Right.
they start.
But he's bringing up a different point. He's bringing up the point is, okay, I just went from here to here. I'm portaled. Back at the beginning. Nothing keeps me from writing start again.
Right.
Start again, which is going to add to my number of rooms, add to my number of rooms visited. Maybe that's okay. But maybe we decide, okay, well, if I'm at the very first room, I shouldn't be able to go back to the very first room. I'm already there. That shouldn't count against me. So start maybe either shouldn't be an option or shouldn't be effective. Okay, so if I'm in a room and I type in start, I only want to actually take the portal if the room I'm trying to enter is not the first room.
So
How do we check that? Who knows about the current room the player's in?
the player,
Player. Who knows about the starting room for the cave?
the wizard.
The wizard, the stats, okay? So right now, the way we have this written is if I go to start, we'll go to our current cave and we'll tell the player to enter this cave. And that's this guy right here. Where we set the player's current room equal to this cave's entrance. So you're saying you only want to do this if they're not already in that room, right? So does a player currently expose their current room?
Not until they display it or look around.
Well, I guess by expose, I mean they have a private variable here called cur room. Is there a way to access that from outside of here?
If you make it public
Yeah, but that's bad programming.
for you guys.
The question we're interested in asking here is whether or not whether or not we're already standing in a room that we might move into. Okay? So maybe we have a public Boolean is equal, let's see, is already in room R, and this guy will return this dot cur room equal R. Is my current room the same memory address as the room I'm about to go into? Are they indeed the same room? That make sense? So we've just added an ability to player that we can ask a player, hey, is this the room that you're already in? If yes, I won't put you back in there. Make sense? So now we can ask a player that question.
So if that room doesn't equal R.
This will return a false.
Okay.
So this dot current room is going to be some room, a pointer, a memory address of a room. R will be the memory address of a room. If these are the same memory address, this will boil down to a true. If they're not the same, it'll boil down to a false. And it'll return a Boolean true or false. So now in Cave, we're only going to set that player's room to set cur room if P dot is already in room, this dot the entrance. If that is not true, then we'll do that. Okay. Else, if we just want to add a little verbiage here so we kind of know why we're doing this, we might say system.out.println, you are already in that room.
We cannot put this message in the error method because it's a different situation, right?
Well, that's true. It is a different situation. But more importantly here, we kind of break our logic a little bit because now this is the cave. You know, the evil voice coming from the walls. You are already in that room. All right, so you know it's kind of coming out of the walls. But if that happens, we probably want to show the menu again, right?
Yeah.
Well, who knows how to show the menu?
The player has.
Player does. So maybe for simplicity's sake here, we just say, if a player keeps pressing start, they have to deal with the evil voices from the walls over and over again, and they maybe have to just scroll up and look. You know, hopefully they're not an idiot for too long. Otherwise, we're going to have to modify our our look around method, where the cave kind of manipulates our players. Like, you are already in that room. Hey, look around. And then he goes and looks around the room. Make sense? We could do it. We could certainly do it. I just maybe don't want to break our logic too much. Otherwise, you start handling every little situation that might ever exist. But now we should have the ability. Let me check in player real quick. So display menu, ask them if they want to start or not as well. If they entered start, we'll grab the current cave. We'll try to enter that room. If that player is not already in that room, we'll go ahead and let him enter it. Otherwise, we're going to scream at him.
Okay, so this method is just deal with the entrance, the cave.
Correct.
What about the room that user has visited, that the player has visited?
Well, I mean that's on you. That's part of the game.
Because I don't know, probably the cave has more than 50 rooms. How can I, memorize all the kind of rooms?
Be smarter.
So to be like,
Maybe take a piece of paper and draw a map what you're doing. And that's part of the game. It's a memory game,
okay,
right? I mean that is the game. Yeah, if it has 50 rooms in it, that means that you've been practicing your memory pretty well. Maybe we can add in a feature where after you've taken so many steps, some multiplier of the number of rooms that we're just going to say, okay, you're out of luck. It's game over, okay? But for right now, we're just going to say that you can just keep going until you're done.
you mean like that to become winner, you have to get all the treasures inside the cave with the minimum steps or moves?
Not the minimum.
Okay.
You have to collect all the treasures in the cave. For right now, the game is simple. You get to move on to the next level, the new cave, if you have collected all the treasures in the current cave. So collecting all the treasures in the current cave means you visit all the rooms that have treasure in it. Not necessarily all the rooms, but all the rooms that have treasure in it. Okay? Maybe you want to also display the number of treasures that are left, so you kind of know your progress. But that'll be part of, if you want to do that for your homework assignment.
I mean, I can make the player look through the mini rooms to see if there's treasures without to move any steps.
Well, sure, but I mean, the player is going to be playing this game. So I'm saying that you might want to give them kind of a countdown, like, number of treasures in this cave is 13. So they have 500 rooms that are in front of them, but only 13 of those rooms have treasure. So in order to go to the next cave, you have to visit those 13 rooms. We don't know where they are, but they're somewhere in there. That make sense?
Yeah.
Okay. So let's go ahead and just test this real quick. Make sure this is doing what we want it to do. So here, we'll go ahead and test our start real quick. This should yell at us. This is the evil cave voice. You are already in that room. Duh. All right. So otherwise, let's go ahead and put in a number. It is broken. We do need to rewatch because we already read in the. I hate that. All right, fine. Oh, we actually already made look around public. I don't know why we did that, but fine. So you're already in that room. The evil voice then has a strange effect on you as it grabs you and tells you, look around.
I'm about to have so much fun with this.
What would you like to do? Well, I'm going to portal back to the start. You are already in that room. Then you look around again, blah, blah, blah. All right. This isn't exciting?
Yes, it is.
All right. So, questions about what we've done so far? All right, let's quickly look at the homework assignment. Make sure I've given you everything you need to do it. And then we also need to look at the paper because I think I want to update the paper. Guys, I don't remember what the topic for the paper was. But usually, somewhere in the class, I usually make topics relative. At some point, it branches away from like the programming part we're doing. So a lot of times the topics are something relative to like the news right now or something that's happening in technology. Somewhere in here, I think there's like a Bitcoin paper, which isn't uninteresting, but well, maybe. But it was really the news from last time I taught the class, where maybe I want to modify it a little bit this time.
Speaking of the news, did you hear about the idiot semi driver who drove an 18-wheeler all the way to the Lions Bridge in Lake Park?
Mm-mm.
Yeah, he said the GPS took him there.
Okay.
And he got the 18-wheeler stuck in the Lions Bridge.
Oh, nice.
No, not nice, because those things were 120 years old. Now they're all chipped up and broken.
Huh.
No.
It's part of the history.
No.
Now there's been a semi there.
People were freaking out. They took them to the mental health complex to get them checked out.
All right, so extend our crawler program, and I'll attach our version of this, our current version, such that the game goes on until a user finally loses. The game should start with a map of size 4.
A
So a couple things that you're gonna, well, a cave map. This is like a map.
Oh, you mean where it said?
This is a map. Yeah, you don't have to display a map, just you're gonna have a cave size of 4. So your very first cave might look like that.
Okay, because before we had 3, so then we're just changing.
No, not the number of exits. Right now we have the number of possible exits something has is 2, 0 or 1, less than 3. So what I'm saying is level 1 is always 100% a cave with 4 rooms in it. Okay, so you'll have to figure out as part of the assignment, how do I make sure that my cave only has 4 rooms? No more, no less. That make sense?
Yep.
Okay, so that's part of what you'll have to solve for your homework assignment. Okay, so the first map is size 4. The next is size 6, then 8, and so on. So we'll always increase by 2. So once they beat level 1, then we'll create a brand new cave that's 2 rooms bigger. So level 2 will be size 6, and we'll stick the player into that room,
Question.
that cave. Go ahead.
How long are we supposed to go up to?
Well, let's see if I say something. I mean,
Okay.
really, it should work forever. The algorithm, I mean, we're always just adding 2 to the number of rooms, so it shouldn't matter.
That's
Yep.
a valid point.
Okay, so winning a cave means that you found all of the treasures within the number of moves available. Okay, so for our example here, we're just going to say they have as many moves available as we want. Okay, for each cave, a new set of stats should be established. You should be able to accomplish this with our reset method. Okay, so we need to go ahead and write a real quick reset method in stats to bring that up to date. So
the key for that, we just move the random of the ones because we put something random to create the map of the cave.
well, there's many different ways you can force a cave to be the right size.
Yeah.
All right, so inside stats, we're going to have a reset method. So static void reset. And this method will just go through and set num rooms back equal to 0, num treasures back equal to 0, and cur cave equal to null. Probably we want to start cur cave equal to null as well. All right. So now we have our reset method. So when you generate a new cave and you're ready to start a new level, stats resets. Okay. All right. Okay, now this does say within the number of moves available. So you can kind of make a decision on this. If you want to give them unlimited moves, you can. If you want to give them a number of moves that's maybe 3 times the size of the number of rooms, that would be fine too. So you decide. That kind of goes in with how you write it and how you want to test it.
Are we still making like the treasures random?
Yeah, treasures are still random. Everything's the same as it is now.
Okay.
Except we're already keeping track of the number of treasures they have picked up. Just as soon as they pick up the final treasure associated with a particular cave, it generates the next cave and puts them into it. They won that level. Now it's time for a new cave with new stats. The players also need to have their everything reset in their method. They no longer have collected any treasures. They haven't visited any rooms because they're in a brand new cave. That make sense? Okay.
What if there's no treasure in the first level? Should you go to the second?
Probably, yeah. If the from a logic perspective, if the user's number of treasures is equal to the number of treasures in this cave, then they're done with the level.
Yeah.
So if by a dice roll they walk into a cave with no treasure in it, they instantly go to the next cave. They just got lucky. So if the cave with 4 rooms in it has no treasure in there, they'll just instantly go into the cave with 6 rooms.
Okay.
So that'll just kind of be a weakness of our, of our game just because of the random nature of it. All right, so questions about this? All right, so let's see what I was asking you to do for the paper and see if it's... Yeah, we don't want that. So I think I updated the last paper to be more in line with incorporate this into it. So let's modify this. Let's see. No, I gotta have a paper. It's part of our curriculum requirement now. I can make it longer. Let's see, what would be a fun topic? It has to be at least loosely related to what we're doing.
We can create a game that will go with what we're doing.
Like a storyline?
Yeah, that'd be cool.
Nah.
Yes.
It actually isn't a bad idea, but I actually think that might be a difficult paper to write.
Oh, wait.
Okay, just one question before that. About the password crack, can you use our method, our like program for for password cracking?
What?
So when you're gonna
I think the stuff from the tea's kicking in.
Yeah.
No,
That's
about the
that
password.
extra seasoning he
When
put.
he got the password, when he going to crack the passwords.
Collect the passwords.
To crack. Like search.
Okay. So you're talking about cracking passwords.
Exactly.
Okay.
So he's a hacker.
Okay. Yeah, I got it.
We use our games for that
In what way?
to catch the password. To
What
figure out the password.
passwords are you trying to crack?
Well, I mean, I suppose you could write a game related to that. That every cave is like a combination lock, and you need to collect treasures in the right order or something like that. So maybe you get to choose whether you pick up a treasure. So you could certainly take our game to the next level and make it more difficult to implement. But maybe you have to pick up the treasures in the right order. If there's 5 treasures, you can't pick up them just as you run into them. You got to get them in the right order. So that's what unlocks the at the end of the cave. There's a door. And maybe that actually becomes a later on thing, not for this assignment, but for this assignment, I think what we say is just automatically put him in the new cave. But let's say after you picked up all the treasure, the mysterious voice from the cave, you hear a stone door sliding or something like that, which means at the end of the cave, there's a new entrance that this was created that goes into the next cave. So you're like going down to the dungeon. You get it? So that we're not going to do that for this. Because that actually would make the game harder, because now you're reliant on the user to now traverse the cave to get to the end room again. And then what is the end room? So whatever room we put that exit in.
I think the storyline paper would be more fascinating. It'd be an enjoyable read for you.
Well, I really do think it would be a hard paper to write. Being creative and really thinking through something like that, I think, is more difficult than researching a topic and writing about it from a time perspective. I think it really is. Well, it might be true. There's actually a new piece of technology. I'll make sure I get the name of it right. Should be on the main page here, isn't it? Yeah, the thing that's like kind of like Siri for your living room. What's it called? Here, let's just do Amazon Siri.
Okay, so
Amazon Echo.
it's like the
Amazing.
That's pretty cool. So research that.
Yeah, so I think that'll be kind of a fun thing to look at. So write a 2 to 3 page paper discussing the Amazon Echo. You can find initial information at this. You may want to look at various sources for reviews and opinions. Discuss how technology like this will change the way we do things at home and may impact the way we do things in the future. Something along those lines. Okay, and just to give you a precursor to this, Echo is kind of like this product you'll have in your living room that you can just talk to. So like if you have your phone now, you either have Siri or something, your personal assistant thing you can talk to. Well, Echo is going to sit in your living room and you could just say something to it. You can say, Echo, I need a recipe for meatloaf. And it'll, yeah. So I mean, it kind of an interesting thing like that. So it's another device. Now, we'll talk obviously about it next week, but
You see the video about it?
there is.
Yeah,
Yeah.
that's about it. Alarm.
Yeah, but my gut feeling is this might be kind of like Google Glass, where it's not a very good product initially, but it's kind of a foray into something where maybe we're going. Like I have a pair of Google Glass, and have any of you used Google Glass before? I mean, it's really unusable. That doesn't mean it was a bad idea. It's just not a consumer product yet. I think we're moving towards wearable technology.
It's so expensive.
Well, it's not even publicly available. You have to go through their developer program to get it. But but certainly you're right. Nobody's going to pay $1,500 for a wearable piece of technology. But if you can get it down to $200 or $300, then maybe. But it also has to have a utility. It was one of those things where I got it and it was fun to mess with for about 5 or 6 hours total, and then it just became the nuisance. So the only real use I found for it was like if you went to a party or something like that. It started conversations because people saw you wearing it, and you could just record the whole party. I wore it to our baccalaureate at graduation last December.
Right.
So something like that, baccalaureate from a professor's perspective, that type of thing. But outside of that, I'm not sure it has a whole lot of utility. So I almost think that this might be along those lines where you have this tool in your living room that is supposed to, kind of like Google on hand, if you will, something along those lines. So it might kind of just be one of those things. I also, similar to how Google works, Amazon typically does not come out with products that work, I guess is, like even with Google, we typically hold Google up on a pedestal, right? Historically, Google tries a lot of things. Historically, they've only succeeded at a few. Obviously, search, right? They're pretty good at search. Okay, they got that guy. But Gmail was another win for them. Google Docs, probably another win for them.
Google Map.
Huh?
Google Map.
Google Map, yep. But they've had tons and tons and tons of test projects they've put out there that were flops.
Like what?
Okay. Oh, I mean, there's literally like tons of them. Well, I mean, Google Glass would be an example, but there's not. I mean, I can't necessarily come up with one off the top of my head, but there's hundreds. It's actually built into Google's ecosystem. So if you work for Google, you work Monday through Friday, let's say, they give you 1 day a week to work on whatever you want. They pay you to work on your own project. But built into that, they have first dibs. If you have a project that turns into something real and you want to sell it, Google gets the first opportunity to buy it from you. So that's kind of cool that your boss is going to pay you to work on something that might ultimately lead to you leaving the business. But it's kind of Google's way of driving innovation within the company. But part of that is they get into a lot of different things. So you asked for an example. For instance, Google put a lot of money into the technology that was competing with 4G networks for cell phones. They were working with Sprint. When Sprint had their own version of 4G, that really didn't take off. Google invested a lot of money into that. And in the end, Sprint ended up jumping onto the GSM bandwagon, as did Verizon. They got onto the same technology that AT&T is using. Part of that was driven by iPhone, obviously, right? I mean, all these cell phone providers want to make money, so they're going to go where the money is, where the customers are. So you can, people can complain, oh, well, Android's better than iPhone. Well, iPhone's driven a lot of business. right? So whether it's better or not, that's going to be a personal opinion. But Sprint changed their whole business model because of the iPhone, as did Verizon. Verizon was very much going down a CDMA technology path, and when it came time to them getting onto, bringing iPhone onto their network, which it wasn't on initially, they had to make a decision. So they had to make, an agreement with the devil, with Apple, so that Apple will provide a CDMA iPhone as long as Verizon decides to move over to GSM for the future. So Verizon was forced into that. Funny backstory to that is that, did you know that Apple went to Verizon first? When they first had the idea for the iPhone, Apple went to Verizon and offered them the exclusive for the iPhone, not AT&T. Verizon turned them down. But hindsight's always 20/20, right? Like, okay, we know who Apple is, but they don't make phones. Back when the first iPhone was announced, this could just be a fluke device. Come out with a phone, the phone ends up sucking, and nobody wants the phone. Why? And at that point, from a phone perspective, Verizon was top dog, right? So AT&T became a major player in cell phones because of Apple. It's kind of interesting how history kind of does that. But so really look at this Echo from that perspective. My gut feeling is just that Amazon typically tries to come out with devices that, especially lately, that have really flopped. The Fire Phone has not done well. I really think Amazon's going down a bad path with their tablets and their phones because they're trying to create their own ecosystem within Android rather than just riding the Android ecosystem. So if you have an Amazon Fire tablet or an Amazon Fire phone, you can't use the normal Android marketplace, the Google Play marketplace. You have to use Amazon's version of that. Okay, so they take you out of the ecosystem that has the million apps, and they put you into the ecosystem that has 100,000 apps, and very much kind of lock you into it. So from a user experience perspective, maybe the Amazon Fire user interface is friendlier. Grandma can probably use it because if you've ever used an Android phone, once you get used to it as technologists, it's easy to use, right? But initially, it's a little bit cryptic. Like, where is crap? Right, you got to get used to where stuff is. The Amazon Fire has a lot less moving parts. They've kind of laid an interface on top of Android to make it, less capable, but also less cryptic. So I think this will be an interesting thing to research. All right, questions about any of that? All right, we'll call it quits there. I'll go ahead and upload our video, but I'll also zip up the code we wrote today, so you guys are working off of our starting point rather than last semester's starting point. And I'll see everybody next Wednesday, but not the following Wednesday. We'll talk about it next Wednesday, but remind me.
Okay.
All right, have a good one, and wish me luck getting on my game at 2 a.m.
Yeah.